Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do each and every Wednesday, which is help you feel more competent and confident in your math skills. Help you feel more competent and confident in your math skills. We did take a couple of weeks of break just due to the holiday season and all of that. So happy new year. Welcome to 2026. We are excited for the new year and what this new year has to come, and hopeful that the new year means it's your turn to pass your certification exam. And so that is what we're excited about and what we're hopeful for. I am Amy Sink. I'm from the Central Florida area, and I am an assistant principal of a middle school and high school. And I've been in education for about 15 years. So yeah. If you've been with us for a while, you're probably looking at me like, what did you do? I chopped my hair off. It used to be like way down to here, and New Year, new me. So I chopped my hair off. It was just getting too, I don't know. It was just like, I was done with it. So if you are new, that's what's different. That's what's kind of going on. And sometimes that's just what you have to do for a new year. So we'll see how long it lasts, and we'll see if I grow it out and never chop it off again. I don't know. But I am excited that you are here. If you have any questions while we are working through problems, please don't hesitate to ask me. That is what we are here for, is to answer your questions and help you feel more confident. I always have a next week section. So if there is something that you want to see me go over in the upcoming weeks, please let me know so that I can add it to the upcoming weeks. Don't be shy. These sessions are for you. As much as I enjoy doing them and I enjoy being here with you guys, these sessions are for you. So if you have topics that you're struggling with, questions that you're struggling with, please let me know, and I am happy to add them to the next week section. I always like to do a get to know you. So where are you from? What test are you prepping for? And get to know you question. Get to know you question is going to be, what New Year's goals do you have for yourself? Is it to pass that certification exam? Mine is to just cook more at-home meals. We go out a lot, and so mine is just to cook more at-home meals. So where are you from? What test are you prepping for? And what goals do you have for the new year? Maybe they're big goals. Maybe they're small goals. Maybe you don't have any goals at all, and you don't like doing New Year's goals, and that's fine too. But that get to know you question just helps it feel a little bit less like a computer screen and a little bit more like we are together. So without further ado, let's go ahead and get started with our first question. Which of the following is not a zero of the function below? Which of the following is not a zero of the function below? Which of the following is not a zero of the function below? All right, to solve this problem, I think I dropped my pen, I did. To solve this problem, y'all, there is an easy way to solve it, and there's a not so easy way to solve it. So when we're doing these tests, I encourage you to look for opportunities where you can use your answer choices to help you. When we're solving these tests, I encourage you to look for opportunities where you can use your answer choices to help you. So you may see this and you're like, man, I don't know how to factor something to the x to the fourth power. Like, give me a quadratic and I can do that all day. But x to the fourth, I don't know what to do with that. Y'all, that's okay. It says, which of the following is not a zero of the function below? There's a little puppy dog nose. A zero is something that makes the function equal to 0. So if I plugged in each of these answer choices into my x values and I solved with my calculator, because if you have a problem like this on your test, I can assure you have at least a 4-function calculator. If you solve it and it equals 0, then it is a 0 of the function. If you solve it and it doesn't equal to 0, then you have found the not a 0 of the function below. I enjoy working with positive numbers just a little bit more than I enjoy working with negative numbers. So I am going to plug in my positive numbers first. So I see that somebody's asking what kind of dog he is, that he can like walk up to me. He is a Great Dane. He is 160 pounds. He's a massive boy. So that is why I am literally sitting at a table and his head is right here. Which of the following is not a 0? So I like working with positive numbers. So I am going to plug in this 2 first. So 2, plug 2 in anytime you see an x. 2 to the 4th minus 2 to the 3rd minus 42 times 2 to the 2nd plus 16 times 2 plus 160. So I'm going to use my calculator to help me. There's no reason I shouldn't. 2 times 2 times 2 times 2 is 16, times 2 is 32. 32 minus 2 times 2 is 4 times 2 is 8. Minus 42 times 4, 168, plus 32 plus 160. 32 minus 8 minus 168 plus 32 plus 160. That equals 48. Would you look at that? B is going to be my answer because this equals 48. It is not a 0. Watch what happens when I plug in the number 4. Watch what happens when I plug in the number 4. 2 times 4 to the 4th power minus 4 to the 3rd power minus 42 times 4 to the 2nd power plus 16 times 4 plus 160. 4 times 4 times 4 times 4 times 2, 512, minus 4 times 4 times 4, 64, minus 42 times 16, 672, plus 16 times 4, 64, plus 160, 512 minus 64, minus 672, plus 64, plus 160, all equals 0. So that is a 0 of the function below. We're looking for not a 0. So this is a 0, which is why we're going to cross it off. It just so happened that when we picked letter B to start with, we got the not a 0 right out the gate. Now, remember when you plug in a negative number into an exponent, sometimes four-function calculators do not understand order of operations. This kind of comes down to some of my lower grades. So this might be your high school, but the concept I'm about to go over is going to bring the level down a little bit. When we are looking at doing exponents with negative numbers, x to the fourth power. If I do negative 2 to the fourth power and I just plug it into my calculator, it might not give you the right answer. So you got to pay attention to that, because we got to think negative 2 times negative 2 times negative 2 times negative 2. A negative times a negative is a positive. A negative times a negative is a positive. So this is going to equal a positive 16. However, x to the third, if I do negative 2 to the third power, negative 2 times negative 2 times negative 2, negative times a negative is a positive. Positive times a negative is a negative. So that would equal a negative 8. However, sometimes when you plug this into a calculator, it's going to spit out a negative 16, because what it's actually doing is it's doing 2 to the fourth power and then multiplying that times a negative 1. So it's important that you understand that concept when you're working with negative numbers and exponents, so that when the calculator might make a mistake because it's just doing what it's programmed to do, you don't get the problem wrong just because you're relying on the calculator too much. Does that make sense? All right. If we were to plug in negative 2 or negative 4 into this equation, we would end up getting 0 as an answer as well. We don't need to check it. That would take too long. Now, if you have extra time and you're dying to check it, then absolutely. But I would not spend extra time checking A and D when I got B as my answer out the gate. Let's go ahead and move on to problem number 2. Which of the following are the zeros of the function below? Which of the following are the zeros of the function below? Now, again, I would use my answer choices to help me. Now, I do not have time to plug in negative 2, 3, and negative 4, and then 2, negative 3, and 4, and then negative 3, negative 10, and 24. I don't have time to do all of that. What I do have time to do is see, are there any consistencies between answer choices? I notice that this answer has a negative 3 and this answer has a negative 3. So I'm going to start with that. I'm going to start with plugging that in and see where it takes me. So I'm going to do negative 3 cubed minus 3 times negative 3 squared minus 10 times negative 3 plus 24. Negative 3 cubed is negative 27 minus 3 times 9. Negative 10 times negative 3 is a positive 30 plus 24. Negative 27, negative 3 times 9 is another negative 27. It looks like my iPad just disconnected, so we're just going to reconnect it. No big deal. Here we go. Share screen. All right. Negative 27 minus 27 plus 30 plus 24. Now I'm going to use my calculator. Negative 27 minus 27 plus 30 plus 24. That equals 0. So what does that tell me? That tells me that one of those answer choices has to be correct, because negative 3 is a 0 of the function. So A is not correct because I have to include negative 3. And I know that D is not correct because the function has zeros. The function has zeros. So now I just need to pick either 2 or 4 or negative 10 or 24, and that's going to give me my answer. So now I'm going to pick 2. It's the smallest positive number that I can work with. Am I afraid of other numbers? No, but this is just going to make my life a little easier. So now I'm going to do 2 cubed minus 3 times 2 squared minus 10 times 2 plus 24. If it equals 0, then I know my answer is B. If it doesn't equal 0, then I know my answer is C. 2 times 2 times 2 is 8. Minus 3 times 4. 10 times 2 is negative 20 plus 24. Drag it up here. 8. Negative 3 times 4 is negative 12 minus 20 plus 24. 8 minus 12 minus 20 plus 24 equals 0, which tells me that B is the correct answer because 2 is a 0 of the function. Questions about this problem? All right, let's go ahead and move on to problem number 3. Jason is building a regular pentagonal garden. He determined that the length of one of the sides is 7x minus 4. What is the perimeter of the garden? What is the perimeter of the garden? 28x minus 16, 35x minus 20, 49x squared minus 16. Not enough information. All right. So when we are told that we have a regular pentagonal garden, that means this word regular immediately tells us that we have a shape with all the same sides. So my pentagon is going to have, and that is not drawn to scale clearly. Let me see if I can do a better pentagon. Nope. Third time's the charm. We're going to try it. That's a little better. We know that all 5 sides are the same size. One of the sides is 7x minus 4. What is the perimeter of the garden? Now, as we're working through problems, we are working through problems that are pre-K through 12th. So some problems we're going to be asking about zeros and derivatives for my high school people. Sometimes we're going to be talking about perimeter of a regular shape, which drops down to late elementary, middle school, GK, Praxis core. Sometimes we may do something that talks about pedagogy or patterning back down into our pre-K or kindergarten or first grade. So we're going to cover a variety of topics on Wednesdays, which is why I asked, do you have anything you want to go over next week? All of the comments I will absolutely take into next week and the weeks following. So when we are looking at a regular pentagon, a regular octagon, a regular septagon, a regular quadrilateral, all of these shapes are going to have the same equal sides. So that means that this side is 7x minus 4, and this side is 7x minus 4, and this side is 7x minus 4. All of these sides are 7x minus 4. Perimeter. What is the difference between perimeter and area? Perimeter is the linear distance around a shape. Area is the square distance inside a shape. So the perimeter is going to be all of the sides added up. So 7x minus 4 plus 7x minus 4 plus, and I'm going to move this up here so I don't run out of room, 7x minus 4 plus 7x minus 4 plus 7x minus 4. Now, some of you might do it like that, and some of you might do it like 7x minus 4 times 5, because I'm literally doing the same thing 5 times. You will get the same answer regardless of how you do it. Let me show you how. 5 times 7x is 35x. 5 times negative 4 is negative 20. That's my answer. Let me do it on the other side. Add like terms. 7 plus 7 plus 7 plus 7 plus 7. 35x. Negative 4 minus 4 minus 4 minus 4 minus 4 is negative 20. And that might have taken you a little bit longer to compute or calculate, either with your hand or with your calculator. But you can see that we got the same answer. So our answer is going to be B. Now, what if it said, what is the area of the garden? What if it said, what is the area of the garden? Let's explore that for a minute. A lot of us don't have the area formula for a pentagon memorized, but let me show you how we might do that. So, I don't think I wanted to do that. I think I wanted to do this. Okay, so what if this said area of the garden? So one thing that we could do is we could create triangles out of this pentagon. And I know that the base of this triangle is 7x minus 4. And then I can drop a dotted line here like that and create an apothem. I can create an apothem, which is just a diagonal line that extends out to that pentagon. And I can do the same thing with a hexagon, and then I can use my formula for an apothem to figure out what that could look like. So we don't necessarily need a formula if we wanted to figure that out, because then I could find the area of this little triangle and then this little triangle, and they're all going to be the same, right? Because I've got 5 identical triangles. So that's one way that you could figure out the area of a hexagon or a pentagon. Let's go ahead and move on to the next problem. Pet Rescue for Life has cats and birds available for rescue. There are a total of 34 animals needing to be rescued. What is the maximum number of cats that need to be rescued if there are a total of 120 feet among the cats and the birds? If there are a total of 120 feet among the cats and the birds. All right, so we have cats and we have birds available for rescue. And there are 34 animals needing to be rescued. So cats plus birds equals 34. The number of cats plus the number of birds equals 34. What is the maximum number of cats that need to be rescued if there are a total of 120 feet among the cats and the birds? So now I have something that equals 120 feet. And feet literally meaning like there's 4 feet on a cat and there's 2 feet on a bird, right? So if I do 4 times the number of cats, I get how many cat feet there are. And if I do 2 times the number of birds, I get the number of bird feet that there are. And then I can get the number of cats that need to be rescued. So now what? What I've just created is a system of equations, and I can solve this algebraically. I'm going to show you how to solve it with a table of values as well. But first, I want to do it algebraically. I think that elimination is easier. It's just who I am, but you can also solve it using substitution. This sets itself up for substitution. So what I could do is I could subtract C from both sides. And I could get B equals 34 minus C. And because B is the same thing as 34 minus C, I could plug 34 minus C into B and solve. That would be substitution. I prefer elimination personally. It's just who I am. So I am going to eliminate a variable. So I'm going to multiply this by -4. And I would get -4C plus -4B equals 34 times 4. -136. And I'm going to add these together. 4 minus 4 is 0. That crosses off. 2 minus 4 is -2B equals 120 minus 136, -16. Divide both sides by -2. And I get B equals 8. What does that mean? B, the number of birds is 8. Which means if I have 34 animals that need to be rescued, 34 minus 8 equals 26 cats. So what is the maximum number of cats? 26. Now, let's duplicate this. And let's solve this using a table of values, because maybe what I just did, you're like, whoa, that was way too much for my brain. How can we do that? How can we do that a different way? So we have cats and we have birds. So this does take a little bit longer, but that's okay. So I have cats plus birds has to equal what? 34. So I'm not going to do 0 cats, 34 birds, 1 cat, 33 birds, 2 cats, 32 birds, 1 cat, 31 birds. Like, we're not going to do that because our answer choices are here to help us, correct? So if our answer choices are here to help us, I'm only going to do the options that are in the answer choices. So this right here is the number of cats. The answer choices is the number of cats. They're asking for how many cats. Well, the answer choices are the number of cats. So if I have 8 cats, 14 cats, 26 cats, 68 cats. Wait a minute. I know that I only have 34 animals that need to be adopted. If I only have 34 animals total that need to be adopted, how can I have 68 cats that need to be adopted? That doesn't make sense. D is automatically out. That is more cats than I have animals in my store. So if I have 34 animals that need to be adopted, how many birds if I have 8 cats? 34 minus 8, 26 birds. 34 minus 14, 20 birds. 34 minus 26, 8 birds. Now I have 3 answer choices because this one's out. With those scenarios, I have to equal 120 feet. So if I have 8 cats, 14 cats, and 26 cats, and I have 26 birds, 20 birds, and 8 birds, 8 times 2, because cats have 2 feet, 16 feet, 28 feet, 52 feet. 26 times 2, 52 feet. 20 times 2, 40 feet. 8 times 2, 16 feet. Are we following? Oh, cats have 4 feet. Wow. Cats have 4 feet. Thank you. Cats don't have 2 feet. Cats have 4 feet. So I need to multiply all of these by 4, not 2. Okay, try that again. 8 times 4, 14 times 4, 26 times 4, 32, 14 times 4, 56, 26 times 4, 104. So when I add all of these together, does 32 plus 52 equal 120? No, that equals 84. That's not correct. 56 plus 40 equals 96. That does not equal 120. 104 plus 16 equals 120. So C is my answer. So if the whole system of equations didn't work for you, then do it logistically. Like cats plus birds has to equal 34. Use your answer choices. Then once you have your answer possibilities, then figure out how many feet each of those scenarios produces to see which one is correct. Questions about that? All right, let's move on to problem number 5. A local schoolhouse is creating snack bags to hand out to students at their open house event. They have 48 packs of gummies, 12 granola bars, and 32 packs of crackers. If they want to create identical bags that contain each of the snacks with none remaining, what is the greatest number of snack bags the school can make? If they want to create identical bags that contain each of the snacks with none remaining, what is the greatest number of snack bags the school can make? So this is an elementary problem all day. This is a K6 problem. It could show up on GK or Praxis score as well, but this is an elementary problem all day. We have 48 packs of gummy bears, 12 packs of granola bars, and 32 packs of crackers. And I want to create identical bags. So a bag is going to have a gummy pack, a granola bar, and a cracker pack. How many of those bags can I create? I can create the number of bags of the item that I have the least of. So I have 12 granola bars. I only have 12 granola bars. If everybody gets one granola bar, how many snack bags can I create? I can create 12 snack bags. However, we want to create identical bags with no snacks remaining. That is the key. With no snacks remaining. So if I do 48 divided by 12 bags, what do I get? 48 divided by 12 is 4. So every bag gets 4. Can I do 32 divided by 12? No, it would be like 2.7, 2.6 repeating. So I'm going to have extra cracker bags. That's a problem. So my answer is not D. Let's try C. If I make 6 snack bags, can I divide 48 by 6? Yes. Can I divide 12 by 6? Yes. Can I divide 32 by 6? No, I'm still going to have leftover snack bags. Or I'm still going to have leftover crackers. 4. Can I divide 48 by 4? Yep. Can I divide 12 by 4? Yep. Can I divide 32 by 4? Yes. So 4 is going to be the correct answer here. That was a tricky question. That is a GCF problem, a greatest common factor problem. I'm looking for the largest, the greatest number of bags I can create with no snacks remaining. Those are factors. And that right there is not what you read into the problem when you first read it. The number one error that people are going to choose is 12 because they're like, oh, there's 12 granola bars. That's got to be the answer. But then I would have leftover crackers. So we got to pay attention to those smaller key details that are going to trip us up on these exams, especially when we are stressed to the max. Let's go on to the next problem. A theme park survey found that the average age of a park attendee was 42 years with a standard deviation of 5. Which of the following is the best interpretation of this result? Of this result. Which of the following is the best interpretation of this result? A, the oldest park attendee that day was 62 years. Most of the park attendees were younger than 32. Most of the park attendees were younger than 47. Most of the park attendees were older than 47. So this is an interesting one. So standard deviation is fun. 99% of you are not going to have to actually solve for standard deviation, but you do need to understand it. So a standard deviation, a standard bell curve looks like this. When I distribute my data, most of my data is going to fall here. And then it tapers down, right? So if I create my average right here, one standard deviation, and don't get hung up on the vocabulary. If you're like, I don't even understand what one standard deviation is. They told you one standard deviation is 5. 34% of your data is going to fall there. Then about 13% of your data is going to fall there, and about 2% of your data is going to fall here, right? And these are all standard deviations. So what does that even mean? Like how in English, please? The average age was 42. So 42 is my average. It goes in the middle. And the standard deviation is 5. So 42 plus 5 is 47. 42 minus 5 is 37. 47 minus 5 is 47 plus 5 is 52. 52 plus 5 is 57. 37 minus 5 is 32. 32 minus 5 is 27. So what does that all mean? All I did was I added and I subtracted 5, one standard deviation from my average on each tick mark. Now, that means that approximately 34% of my park attendees are between 42 and 47 years old. Approximately 34% of my park attendees are between 37 and 42. Approximately 13% of my park attendees are between 32 and 37 and between 47 and 52. Approximately 2% of my park attendees are between 52 and 57 and 27 and 32. Is that exact? No, this is all estimates. Do I have exact data? Do I have exact data? I don't. I don't know the oldest, the youngest, the mediumest, the most, the least. I don't know any of that. All I know is average, approximates. So if you have a standard deviation question like this is GK all day. If you have standard deviation questions like this, we don't know what the oldest park attendee is or the youngest park attendee is. So if you see something like that, A is absolutely out. I don't know who the oldest person is. I don't know who the oldest person is. I don't know who the youngest person is. There could be an outlier to the data. There could be an outlier to the data. Now, most is more than 50%. Most is more than 50%. Most of the park attendees were younger than 32. Younger than 32, and I'm going to use different colors to delineate this. Younger than 32 is here. Is that most of our data? Is 2 most of our data? No. Younger than 47. All of that is younger than 47. Or older than 47. All of that's older than 47. Which one is most? Purple. C is going to be the correct answer. So you don't even have to be a statistics expert to be able to figure something like this out. All right, let's move on to our next problem. Find the slope of the line tangent to the vertex of y equals 2x squared plus 8x minus 1. Find the slope of the line tangent to the vertex of y equals 2x squared plus 8x minus 1. Okay, this problem is for my upper level math, 7 through 12, 6 through 12 people. I want us to imagine, before we start freaking out that we don't know how to do derivatives, I want us to consider, what does this look like? A parabola, an up parabola, right? The squared tells me it's a parabola, it's a U-shaped graph, and the positive 2 tells me it's up. So it doesn't really matter where that is. I'm just going to put it here. Is it there? I don't know, but that's where we're going to put it for today. And that's not the best parabola I've ever drawn. Let's draw one more there. That's a little better. And we're looking for the slope of the line tangent to the vertex. Here's the vertex. There's the line tangent to the vertex. I don't need to understand how to do derivatives, which first derivative gives us the slope of the line tangent at a specific point. I don't need to know how to do any of that. If I can just visualize this, what is that slope of a horizontal line? Any slope of a line tangent to a vertex of a parabola is going to be 0. Of a cubic function is going to be 0. Of a fourth function is going to be 0. Because that vertex is the maximum or the minimum point. And so when you draw a tangent line to that, your slope is going to be 0 because it's going to be a horizontal line. Now, you're like, okay, that's all well and good. How do I do it tangent to a different line? Great question. Find the slope of the line tangent to the point on the same parabola. So here's my parabola. over 1, up 9. Let's say that's our point. And I'm looking for the slope of the line tangent to that, right? That's not a great tangent line, but we're going to call it what it is. How do I do that? Slope of the line tangent is your first derivative. So I'm going to find the first derivative of my function, and then I'm going to plug in the x value of that to solve. So y equals 2x squared plus 8x minus 1. F prime of x, so first derivative, drop the 2. So 2 times 2 is 4x, subtract to the first power, plus 8. Plug in 1 into that. So the derivative at 1 equals 4 times 1 plus 8, which is 12. So D is the correct answer. Pretty self-explanatory, pretty straightforward if you're a high school person. If you're not a high school person, then you don't need to know how to do that. We have time for about one more problem, so let's go ahead and explore that final problem, and then we will turn it back over to Dr. A. A student was asked to compare the fractions 3/4 and 5/8. The student stated that 3/4 is less than 5/8. Which of the following best identifies the error in the student's analysis? Which of the following best identifies the error in the student's analysis? The student did not find a common denominator before comparing the fractions. The student incorrectly compared the numerators without considering the fraction as a whole. The student mistakenly inverted the fractions when comparing them. There is no error. The student's analysis is correct. So 3/4 less than 5/8. If I get common denominators just to make sure that this student is or is not right, multiply this times 2 so that I have a common denominator of 8. 3/4 is actually greater than 5/8. And the student said that 3/4 is less than 5/8. So there is an error here. Which of the following best describes the error? Y'all, this is where all of us kind of cringe because we're like, best? Why are we looking for the best answer when there could be more than one correct answer? Yep, this is the specialty of these teacher exams is they ask for the best answer, not the correct answer, right? So the student did not find a common denominator before comparing the fractions. That's a possibility. So, yep, possible. The student incorrectly compared the numerators without considering the fraction as a whole. Possibility. The student mistakenly inverted the fractions before comparing them. So that means they got 4/3 and 8/5. Possibility. Is that a common thing for students to do? No. That is not the best identified error. The best identified error, the most common error that we see is that they compare the numerators without recognizing that it is a fraction as a whole. That's the error. They think that the numerators matter. If they had found a common denominator, then they would have gotten the right answer. But the error is not that they did not find a common denominator. That would be the process. The error is that they compared the numerators. And so that's why B is just slightly better than A. In this situation, if you said A, my brain would be like, that's absolutely correct. But that's not the error, that's the process. The error is that they thought that they could compare the numerators without looking at the whole fraction. And the way that we look at the whole fraction, the pathway that we take for that is finding common denominators. Does that make sense? That's kind of like a lot of words, and we're all mathematicians, not English majors. And so that is a lot of words for a math test, right? That's the frustrating part here. All right. As always, please let me know in the comment box what you want to see me go over next week. I will take that information and I'll add it to my next week section. I hope that you have a great week this week, and I look forward to seeing you next Wednesday. I am going to turn it back over to Dr. A. Thanks for joining me today, and I hope that you have a great week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.